This is the experiment of biprism. We have to do the biprism experiment to find out the wavelength of sodium source. This is the ray diagram. This is the ray diagram for biprism. This is the observation table for biprism. This is biprism. If you look at this prism, you will find the joint between these two, that is, prisms are cemented together, and hence the name biprism. One surface is angled surface and another is plane surface. If you move the finger gently on the surface, you will find the jumper, that surface is angled surface. You have to mount this prism such way that the angled surface is facing to the source. The arrangement which you seen in cylindrical obstacle is exactly similar for this biprism experiment. On this stand, handle with care and confirm that angled surface is facing to the source. Initially, open the slit completely, and as you see in shadow in cylindrical obstacle, you will find a bright part on the screen. You will find the central part is bright, and on both sides there is less intensity. This central bright part you have to focus in eyepiece, and by reducing the slit width and adjusting the tilting screws, you will get the fringes. We have to reduce the slit width, adjust the tilting screws, and very good fringes are obtained here. The fringes in this experiment of biprism are very compact. So in cylindrical obstacle we have taken for 4 fringes separately for each fringe because they were well separated. These are compact fringes, so we have to take the reading for 4 fringes. Just the cross section of cross wire on leftmost fringe and called it as zeroth fringe, not necessary 0. The zeroth fringe reading we have to take on the same scale which you used in cylindrical obstacle. Then after counting zeroth, you have to count first, second, third and fourth. On fourth fringe, you have to take the reading on the scale. Then on 8th fringe, 12th fringe, 16th fringe and 20th fringe. After recording the readings, we have to find out the distance between 2 consecutive fringes, that is the distance between 4 fringes. These are the distance between 4 fringes, and we have to find out the fringe width. So take mean of all these and divide by 4, you will get the fringe width. You have to find out W1. This is the fringe width W1. Again, this capital D is the distance from slit to eyepiece, as you seen in cylindrical obstacle. Part of this experiment, we have to find out magnified and diminished images. Mount this stand over here. Lens on this stand in between eyepiece and biprism, and see that the light is incident on this lens. Slit and increase the intensity of light which is incident on the lens. Convex lens on this stand, and you have to see the magnified images on the screen. Focus these images in eyepiece to see the images in eyepiece and take the reading for both lines, magnified lines, left reading and right reading, and difference of these two readings gives the A. Lens towards the eyepiece, you will find diminished images. These are very close lines, and for this lines, again by focusing in eyepiece, you have to take reading the difference between two diminished lines. Magnified images, A left reading, B right reading. Difference of that two is D1. Then reading for diminished images, C and E, difference for that two is D2. And D is equals to under root of D1 D2 gives the value of small d. Substitute this value of small d in given formula. Lambda is equals to dw upon capital D. This small d is we got from this first table, and this w is the fringe width which is obtained from this table, and this is capital D is the distance between slit and eyepiece. By substituting the value, we get the wavelength lambda for the monochromatic source, that is sodium source. Again, its standard value is 5893 angstrom unit.